Hello, good afternoon, everyone.
Afternoon, sir.
Good afternoon, sir.
Good afternoon. Sorry for today's notes. Actually, I think last night I add one more slide. So if you want the latest one, can you please now while waiting, you can get the notes from the Moodle, the latest one.
Good afternoon, Mr. To.
Hey, good afternoon. You all may sign the instead now.
Okay, thank you, sir.
What's the time? Because my laptop's one is not the same as my handphone. Handphone is already 3 o'clock. Okay. Good afternoon. Okay, so let me start recording. (103) students. Okay, good afternoon, everyone, and welcome to today's lectures. This is lesson 8, I think, if not mistaken. And I will going to start for the chapter 3. So chapter 3 onwards is the new topics for you all. So now before I start, I would like to talk about this quiz 1. The quiz 1, I believe all of you already received the scripts that I returned through email. And the highest marks is, of course, I think you know, is 10 marks. So some students can score 10 marks. And then the lowest, some students also got score very low. Some got 1 marks, also got 0, also got 2, also got 3. So I hope you take because all the modules, the passing mark is 40. So that means if you less than 4 marks, that means it's considered fail for my part. Okay. And actually, if you ask me, I would say that you at least you should take 6 and above. So this, as I mentioned earlier, this is actually the quiz 1, quiz 2 midterm test is the chances for you to score and get the marks. The average marks for this quiz 1 is 7.9. Okay. And then the solutions I already post to the Moodle. I would like to share now with you to show you
so what you're trying to say is that you fell here
solutions,
from another world?
Quiz 1
But when you
solution.
wanted
This is the
to leave and go
solution.
on to the next world,
I would like to show you that
was blocked by
this
some
solution
unknown
actually
guide?
you can see my solution actually is very, very short.
Outlanders.
If you use the
Your journey
you see for the
ends
question
here.
1, what you need to do is just set the gradient same.
Who are you?
Gradient AB same as gradient of BC. and then you substitute value, you'll get the answer for lambda equal to 0, lambda equal to -2. And then the tricky part that I mentioned before is this lambda and lambda, you should not cancel, because if you cancel, you'll get only one value. If you don't cancel, you should get the quadratic equation. So quadratic equations from the high school, you know already, it will give you two answers, two roots for the quadratic equation. But if you cancel one lambda, you wouldn't get quadratic equation, you'll get the linear equation, which is only one answer. So since this is quite tricky, so for those who only give me one answer for this round, I didn't deduct the marks. I didn't deduct the marks due to this trap. So and then some students they use the IJK method to solve. Of course, they can get the answer, but that method is very long. Some using the full page to get the answer. But I hope you can see in mathematics and science, normally we learn a different method, but we try to produce the simplest one. Okay. And you see the second one is also very easy. I think is the structures of the solution. You can see it's very straightforward. What you need to do is that the given two line, you find out what is the gradient M1 and what is the gradient M2, and then you substitute into it. You get the answer taking the tangent inverse. You get the theta between the line, angle between the line. But some students are still they don't use the absolute sign, and then of course if you don't use absolute signs, you will get easier to make the mistake. So some, I think the questions actually I intentionally mentioned about the acute angle, but still some students even they obtain the answer is more than 90, they still accept. But the question already mentioned clearly that this is the acute angle, not the obtuse angle. Okay, so this question also I consider as a straightforward because in terms of the strategy of solving, it is very clear. What you need to do is simply find out M1, M2, substitute, you get answer. Okay, and then you see the C is very part C, even shorter than the previous two. So actually this one, the question chapter 2, so this is the basic concept in the basic things in the chapter 2, because I don't want to set harder one since we just finished it not long before the quiz one. Okay, so that means we finish the chapter 1, chapter 2, immediately we have the quiz 2. That's why I don't want to set too tough one. But anyway, this is a very simple, just test you how to write this AC in terms of the position vector. If you know that, you see this all vector A and vector B is given, this AC equal to 2AB also given. So what you need to do, the only thing I test you is about this OC minus OA or OB minus OA. Only one thing I test you. So this is the meanings of quiz, or just simple things to test. And then unfortunately, of course, some students they still can't get this point. So some they give me, let's say AC. AC they give what I remember is the AB. AB they give OA plus OB. So this AC should be OA plus OC according to them. Then which is wrong. Okay. So now this is about quiz 1, but from the markings, I think a lot of the comments actually I can share. But now at this, now I want to emphasize on one thing is that I would like to. You see I noticed that quite many the students they choose to ignore the symbols in mathematics, physics, and engineering. Of course, the symbols is very important. You must be in futures. You should be an expert of handling or using or manipulating the symbols. Because without the symbols, you can't think in abstract ways. But now what I can notice is that not only this year, actually every year is like that, is that you choose to overlooks the symbols. Let's say AB with the arrow on top means vector points from A to B. But if you don't put the arrows, it means AB is the length of the magnitude of is a magnitude of the vector AB. There are two different things. You understand? There are two different things. Now, what I want you to show is vector, but what you show me is the magnitude. So strictly speaking, I can deduct your marks. You understand? But again, this round, the quiz one also, I don't deduct any marks due to the symbols you use wrongly. I don't deduct the marks. You understand? So let's say if you talk about the money, yes, anything? Someone want to say something? Let's say for the money, you just mentioned, okay, I'm talking about the Malaysia ringgit. Okay, teach you about Malaysia ringgit. But in your solution, you write something about US dollar. This is not the same. You understand? So strictly speaking, I can deduct the marks also, but this round I don't deduct. But I think I should be more strict on this. Otherwise, if I don't strict, I think students will put aside my advice. I hope I use our systems to force you to be serious on all these things, because mathematics is not only about calculations. The concept behind the calculation is important. The concept that represented by symbols is important. But when I mark, I see many just although the calculation is right, but the meaning actually is not is. That means when I read the scripts, I can see that in your minds is quite messy, quite chaos, because you cannot differentiate between magnitude and the vector. When we talk vector, we got two components, two information, but you talk about the magnitude, only one component, so they are not the same. So as a lecturer, I think I should find some ways to force you to pay more attention on this, because otherwise, after you finish this completed the foundation, you go to the UG, or after UG you go to you graduated, and then people very serious about all this, not the trivial things. Actually, it's not trivial. Okay, so that means in short, what I want to announce now is that from midterms onwards, midterms, quiz 2 and the final exam, if you don't use the symbols in my part seriously, correctly, even everything is right, I won't give you full marks. I will deduct some, maybe 0.5, maybe 1, depends. So please be serious about that. Okay, and second things is about these past year questions. I already posed the past year questions for midterms, years 1920 and 2021. I already posted, so you can download and then try to solve for the chapter 1 and chapter 2. So the solutions I will release 1 week later. That means next Monday. Okay. So now that's all for today's announcement about before the chapter 3. Okay, now we prepare to start for this chapter 3. Let me show screen. Share screen. Okay, this is chapter 3. Complex number. It is completely new, I think, for you. So this is a learning outcome. Again, we'll come back to this slide after we finish this chapter. Okay, but to introduce what is the meanings of this complex number? I use these slides to introduce. You see, you try to recall the numbers concept and mathematics that you learn since kindergarten. This is how you develop your concepts about the number. Initially, you study about natural number. Natural number, the symbol is n, capital N. Like this one, this n is a standard symbol for mathematicians. Okay, and 1, 2, 3, 4, 5. We start from 1, 2, 3, 4, 5. We don't introduce 0 initially, but after that, mathematicians they create the concept of 0. So they add the new elements to the natural number. Then we got this new set of the number. We call it a whole number. I'll start from 0 and then 1, 2, 3, 4, 5. So in terms of the size of the set, you can see that natural numbers, the size of the set is smaller than the whole number. And then we have the integer. Integer can be positive integer or negative integer, including 0. Okay, so you see now the size, actually you are expanding the concept in your mind. Now, not only positive, but also negative. You cannot teach, let's say, young boys, I think primary school also, standard 1, standard 2, standard 3. I think they do not know what is the meanings of the negative. Okay, I think when is the time you study negative? Maybe I think it's secondary school, maybe, or standard 4, standard 5, at least. And then after that, you have the rational number. This rational number, the standard symbols is Q. Okay, what is the definition for rational number? It's a number that can be made by dividing two integers. Now these two integers, you take any two, you get and divide them, you get rational number. Okay, like this one, 2/3. If you put it into the decimal point, it should be 1.666666667. So, but you can simplify it into by taking two integers and then put it into the ratio form like this. So it becomes 2/3. But some of the number you cannot do that. Like this pi, you cannot find any two integers and then to get, after you divide these two integers and then you divide that, after you divide them, you got the numbers which is exactly the same as pi. You can't get cert 2, cert 3, cert 5, cert 7 also can. So this side because irrational number. And then we have this real number. Okay, all these are including everything that we mentioned before this above. All is considered as a real number. Now, so that means that up to now, the concept in your mind about this number is only up to real number. So I try to show you in terms of diagram, okay, the relationship between all this set of the number. You can see this. The size becomes bigger and bigger. Natural number, smallest, and then it is a subset of whole number. A whole number is a subset of integer. An integer is a subset of the rational number. You see, rational number and irrational number, they are not they are exclusive in between one another. And then these two are in the set of the real number. So you see, real number including everything. Okay. So before you study complex number, the numbers ideas that you have is only up to this real number. Now we want to include imaginary numbers and the complex number. So we have this another two. Now imaginary number is the number you see in the form that imaginary. This is actually is the I. The symbol is I. You see, what is the definition for imaginary number? It is a number when square give a negative number, give a negative result. Before this, what you learn is that any number, when you take the square, you cannot get negative value, all right? You will get only positive value. Correct not? You take 2 square will give you 4, positive 4. If you take negative 2 square, you will get also 4. So any numbers in the real number, in the subset, in the set of real number, any elements, no matter it is a rational number, irrational number, integer, whole number, natural number, you take any one of them, you take the square of any one of them, you wouldn't get the negative number. But now imaginary number is a new set where these numbers, when you take the elements of, you pick one of the elements from them and then you take the square, the result you obtain is not the positive number, it's a negative number. Okay, so this is a definition for imaginary number. So later I will introduce what is the meanings of I. Okay, I is the symbols that we need to use in this chapter. And if we combine a real number, all these, a real number and the imaginary number, we combine, you will get the complex number. So you see, this all these real number, you plus this imaginary number, you get the complex number. Now, of course, in the test, I wouldn't test you all these things. I wouldn't ask you all this definition. Just introductory concept to bring you into the complex number. So in the complex number, you see two parts of things. You see something plus something, something minus something. Okay, so these two parts, the first part is we call it the real part. The second part is the imaginary part. Okay, so complex number composed of the real part and the imaginary part. Now, what is why we need to have this complex number? Basically, you can say that it is because sometimes we will encounter some situations where when you take the square, root, the things inside the square root is a negative number. Okay, in the secondary school, your teacher told you that, oh, there is no solution, correct or not? So I think I show you this slide. Quadratic equations. When you solve the quadratic equations, there are many different ways to solve the quadratic equation, but the formula, the convenience formula, because the quadratic formula is this one. Why I said it is convenient? Because any form, any different types of the quadratic equation, no matter what is the value of ABC, you can always get the answer for the x, and this answer for the x because the roots, right? So now for this quadratic equation, you already know for y equal to mx plus c, you'll get a straight line. But if it is ax squared plus bx plus c equal to 0 quadratic equations, then in your mind you should be able to see a curve. But this curve got two types. Depends on what is the value of a. If the a is positive value, then you see it will this mouth. I call it the mouth of this curve. It will point upwards. Okay, so here it is written that opens upwards, minimums at the bottom. And then if a is negative, then the mouth is at the bottom. Okay, that means opens downwards. Now for these quadratic formulas, you just substitute what is the value of a, b, c into this formula. You got the value of the x. These things, b squared minus 4ac in the square root sign. I call it the roof. You see, like a roof. B squared minus 4ac, we call it a discriminant. And you already know that these discriminants, they got how many possible circumstances that you can possible to meet. One is it can be positive value. B squared minus 4ac is positive value. B squared minus 4ac can be 0, and b squared minus 4ac can be negative value. So in high school, you only solve the problems that involve the first two cases. Your teacher told you that, oh, b squared minus 4ac means that you will get two different real answer, two different one, value also different. But if it is the same, then you'll get two equal, not difference, two equal, but still the real roots. But when it is b squared minus 4ac less than 0, then your teacher will ask you, don't try, okay? Stop, enough, no solutions. But no solutions, the sentence actually is not complete. No solution for secondary level. It does not mean that no solution in this world. You understand? They got solution. But for the secondary level, no solution. Or we can say that for the real number, because in the secondary school, we just deal with this real number. So in the realms of this real number, there is no solution. You can't get any answer from the real number set. This is the meaning of no solution. But if you expand the boundary of the number, if you expand the boundary of the number to include the complex number, then there is a solution. You will get solutions. And this is actually very, very common in our nature, in our world, in our physics, chemistry, engineering. You will always encounter all these roots with the complex number. That's why you need to study complex number. Okay, but for this chapter, again, I hope you all can clear that you first stage of studying the mathematics, try to be make sure you can master, you can learn, you can understand, and eventually you master the skills that I try to introduce to you at this stage. Because our learning normally is step by step, stage by stage. Our foundations, you learn all this, and then UG, you will learn again complex number. Master level depends on the field. If you need to use it, then the level will be higher. Understand? So for what I want to say is that for this stage, unfortunately, I can only emphasize on the skills that you need to that relates to this imaginary number, the complex number. As I mentioned before, actually, I hope to if we have times, but I don't think we have times, is to try to let you see how the complex number is related to geometry. Because first chapter, second chapter are directly related to geometry. This complex number also, we can use it as a tool to study the geometry. This is one of the usage of the complex number. But as I mentioned just now, I don't think we have time to go deep into it. So please make sure at least after finish this module part 2, you know how to calculate the mathematics involved the complex number. Okay, then in futures when you have chance to study how to apply it, then you already have these skills to understand the application of it. Okay, now so this when b square minus 4ac is less than 0, we say that there is no real root. In terms of the graph, this is the graph I think you have seen in the high school. You see, when the root is equal and real, then actually that means the intersections, because now we are finding the x, right? This is the x value. So that means only one x value you get. So the lowest point, the minimum point, will touch on the x-axis. This is the value of the x, and this is the root or answer for the quadratic equation. If the roots are real and different, then you have two intersection points. But if there's no solution, means that when you plot the graph, you will get this one. It means there's no intersection point with the x-axis. Similarly, for when the a is less than 0. This is for a larger than 0. This is for a less than 0. Actually, this last night I just I add this one, this slide, because when I read through again, I think it is good to add this for you. There's another example I show you why I always keep updating my notes. So now, to solve the third case, another types of the number called an imaginary number is required. We need to use it. An imaginary number, the definition I already mentioned just now, is the number when you square, it will give a negative result. Okay, so this imaginary number, negative, the square root of -1, we define it as square root of -1 is equal to I. Can you see? Let me write down. Square root of I equal to 1. square root to -1. Sorry. Square root of -1 equal to I. Now this I, there is no caps on top, no hat. It is not wearing any hats. So it is not the unit vector. Again, the symbols very important. Please don't mix up. For the unit vector, there's a cap on top, but now there's no cap on top, only I. So this I means imaginary number. So if this one, we define I as a square root of -1. So if you take the I square, what do you get? If you take the I square, you will get the things -1. You will get the things in the square root sign, -1. So this is the meanings of the imaginary number. Now, example, how to find the square root of 28 in terms of I. So in secondary level, there is no solution. Now we try to, I show you how to find this answer, square root of the negative number. Okay, so square root of the 28. So you should rewrite it into this form. You use 28 multiply with -1. Okay, and then this one should be equal to 4 times 7 times -1. Okay, and then this one, I can, of course, the roof, the single roof, I split into 3, becomes 3 houses, 3 square root sign, and then we know that 2 square root of 4 is 2. So you get this is, and the -1, square root of -1 already, just now we already defined, all right? So it should be equal to I. So the answer is 2 square root 7 times I. So this is the answer for the square root of -28. So that means if you take this one square, 2 times square root of 7 times I, if you take the square, you should get answer is -28. Because you take the square of the I, it will give you a negative number. Okay. Another example, solve the equations of x squared plus 9 equal to 0. So this is the quadratic equation. If you substitute into the quadratic formula, you would get b squared minus 4ac less than 0. So now how to solve this? To solve this, okay, we start from this. Rewrite, of course, x squared plus 9 equal to 0. Therefore, now I bring this 9 to the right. 9 to the right hand side. So you get x squared equal to -9, and then you take the square root both sides. You get x equal to plus minus square root of -9, and then now the subsequent steps, you just repeat the one that we discussed here. Okay, so that means I have to multiply this -9 to get -9 becomes 9 times -1. Okay, and then split the square root sign. Okay, but square root of 9 is +3, and square root of -1 is I. So the answer in terms of the complex imaginary numbers is plus minus 3i. So it means that it means what? It means that if you take 3i, positive 3i, you take the square, you will get -9. Because it involves I, you take the square, it will give you a negative number. But if you take the -3i, you take square of -3i, again you will get -9. Answer must be a negative number because it involves the I. Or you take square, it will give you a negative number. So a complex number is a number of this form, a plus bi, where the a and the b belongs to real number. This symbol R means real number. Okay, a and b itself is a real number. I is an imaginary number. Okay, And this a plus bi, the whole thing, we call it as a complex number. Complex number got two parts, two components. One is the real part, the symbol is REZ. Sorry, this one Z means a complex number, a plus bi. So you see, I find a not mistake, like incomplete, incompletions of the note. So later maybe I will add, I will write this as Z equal to a plus bi. I hope you can see why I always update my notes. So now you see this one. Real part means A, refer to A, real of the Z, and B because the imaginary part. This IM means imaginary of the Z. Z is a complex number holding everything. Okay, so I is the imaginary number, B is the imaginary part, A is the real part. Everything is complex number. So I hope you don't confuse. You don't mix up all these concepts. So the complete set of the complex number we call it C. The symbols is the C. You refer back to this one. The whole thing is complex number. The symbols is C. This is all the standard symbols used in mathematics. Okay. Now example. Solve. Just now we mentioned about the quadratic equation, right? So now I give you one more example about these quadratic equations to help you to recall. X squared plus 6x plus 25 equal to 0 is a quadratic equation. So now again we copy the equations and we use this quadratic formula to solve. Okay, and then you substitute value, where in this case A is 1, B is 6, C is 25. Then you substitute value, you should get this. Show me how you substitute value. And then if you simplify, you will get 6 squared minus 4 times 25 is 100. 6 squared is 36. So 36 minus 100, you will get negative 64. So that means B squared minus 4AC is less than 0. Okay, so answer, the roots must be a complex number, not a real number. So you simplify 64. Now you see, now I skip already the steps. Square root of 64, I assume you already understand. Then you can directly write 8i. Before this, I show you the detailed steps. Because I assume you do not know at this stage. But now comes to this slide, I assume you already know. So this negative 64, I directly give 8i. Okay, and then final answer, you simplify it, you will get negative 6 divided by 2 is 3, negative 3, and then plus minus 8i is becomes plus minus 4i. So please take notes. This is not only one answer. This got two answers. One is negative 3 plus 4i. Another one is negative 3 minus 4i. Okay, this is how we use express the answer if it involves the complex root, not the real root anymore. It's a complex root. Okay, so now again, as I keep on reminding you before, is that when you move to the new branches of the mathematics, you must start from the beginning. Because the rules of combinations, addition, subtraction, multiplications, and the divisions that can be applied to the real number, not necessarily can be applied to the complex number. Not necessary. No need to say the needless to say about this interpretation also can be different. So that is why when you move to the new branches, you must check again everything. Okay, how to add, how to subtract complex number. This is the rules. You see, in a complex number, the real part and imaginary part cannot be combined to form a single term. Two real number you add up, you can become one single terms, right? But the complex number, originally the whole thing is two parts. So you cannot real part and imaginary part you combine into one. No, cannot. You must remain real and the imaginary original one in the original form. Okay, so when you add two complex number, you must add the real part and the imaginary part separately. Final answer, you'll get real part and the imaginary part. Same thing happens to the subtractions. I give you an example. Now simplify the following by giving your answer in the form of a plus bi, where again a and the b is a real number. Actually, this one later it will becomes the conventions. It will becomes our common sense or our conventions. Okay. A plus bi again. Sorry, maybe I should say this in this level, a and b always refer to real number. Okay, but if you go to the higher level, not necessary. So you can see that your learning when you go to the master, PhD, your learning, the level will becomes higher and higher, and the things that the boundary that the things knowledge that you have will becomes bigger and bigger. So now, how to add this first complex number and the second complex number? You see, first complex number got real and imaginary. This one also got real and imaginary. So how to solve this? To solve this, the first one, okay. Now for teaching purpose, please, I will. Hey, how come it becomes like this? Sorry, let me copy. Okay, so you have to group and the real part and the imaginary part together. Okay, 3 minus 5 plus negative 4i plus 6i. So your get answer is negative 2 plus 2i. Now, of course, this is introductions level. In the end, later, of course, you no need to show me these steps. You can directly give me answer. Now I assume we are beginning. We are now at the beginning to learn this complex number. So I have to show you the details. And then second one is this. So again, real and imaginary part separately. You add them separately. Your get answer is negative 3 plus 6i. Okay, very simple. That means addition and subtraction very simple. Now we move on to multiplications of complex number. The distribution law of multiplications apply to two complex number give their product. That means the distribution law of multiplications that you apply in the real number still also valid. You can apply it in the complex number. This is the meaning. And since I equal to is defined as the square root of -1, then I square equal to -1. This I already explained just now. So let me show you how to apply this distribution law and this setting to calculate the multiplications between two or more complex number. The first one, you need to multiply. You see, two complex number. This one 3 complex number. Okay, show you one by one. The first one is this one. Okay, so you have to expand this. Two terms. You can expand one by one. You get 4 terms. You get 4 terms. So this is about 8. 2 times 4 is 8. 2 times 5i is 10i. 3i times 4 is 12i. 3i times 5i is 15i square. But you must bear in mind that i square is equal to -1, so that you can simplify later. So you will get the answer now is becomes 8 plus 22i minus 15, because I square equal to -1. So you get negative sign here. So the final answer should be -7 plus 22. So always put the real part as the first part, imaginary part as the second part. Now, if you want to swap can or not, I cannot say no, but normally the standard ways mathematicians and scientists they will put the real part as the first part. Okay, and now how to multiply two complex number. Again, you have to expand one by one. So let's say now I choose to expand the second and the third first. I get 4 times 1 equal to 4, 4 times 3i equal to 12i, negative 5i times 1 is negative 5i, and then negative 5i times 3i is negative 15i squared. Now, if you want to choose to expand the first and the second bracket first, can or not? Can, no problem. This is the meanings of distribution law of multiplication. It's already been proved in the real numbers. Which two bracket you want to settle first? That one doesn't matter. Not important. You finally get the same answer. So if you simplify. If you simplify this, you get, no, sorry, if you expand further, you expand further, sorry, this one, oh, I missed out one line. Okay, you should simplify first. Simplify this one, 4 plus this one negative 15i squared will become positive 15. So you get this one here should be 19. And then 12i minus 5i is 7i. So you should get another new complex number. Then now only you expand again. So if you expand, you should get this one. 2 times 19 is 38. 2 times 7i is 14i. Negative 3i times 19 is negative 57i. And then negative 3i times 7i is negative 21i squared. But i squared is negative 1. So negative becomes positive. So answer should be 59 minus 47i. You see, final answer you will obtain will give you another complex number. So the third example is to show you the what we call it, to show you the properties of the I. Okay, the properties of the I, because it involves 2i power 5 or to the power of 5. So 2i, the whole things, everything in the bracket to the power of 5. So you can use the algebra. So you can know that it can be split into becomes 2 power 5 and I power 5. But 2 power 5 is 32. I power 5, based on the algebra that you learn from Dr. Maxine, it should be I squared times I squared times I. But I squared is negative 1. Now you got a pair of I squared. So negative 1 times negative 1 is positive 1. Positive 1 times I, then of course you get I. So you get final answer should be 32I. Okay, so it is very interesting you should know about the properties of the I. Can you please take a pen and then write down and check. Let's say I is I. I squared is negative 1. How about I to the power 3? Maybe I write down. I is I. And then I squared. Okay. I squared. Do negative 1, right? This is by definitions. And then I to the power of 3. I to the power of 3 is what? It is equal to I times I squared. So should be negative I. Correct? And then how about I to the power 4? I to the power 4 is I squared times I squared. It's negative 1 times negative 1. So you get 1. Okay? So I to the power 4 is 1. How about I to the power 5? You already checked now. Just now we already applied. I to the power 4 is I to the power 5 is I to the power 4 times I. But I to the power 4 is 1. So 1 times I equal to I. So you will see that I to the power 6 is negative 1. I to the power 7 is negative I. I to the power of 8 is 1. So that means the pattern is repeating. It will change from I to negative 1, negative I, and 1. And repeat again, I to negative 1 and negative I to 1. So now if I ask you, I to the power of 28. What is the value? Because 28 is 7 is 4 times 7. That means this I power 4. Okay, this one you see it should be I to the power of 4 times 7, all right? No. Okay. You can write this I to the power 7 and then multiply power 7. Correct not? But I to the power 4 is what? It is equal to 1. And 1 to the power 7 is what? Is 1. So that means when you see the index is the multiple of 4, you will know that the answer must be 1. So this is very important properties for the I. You will need to use it. Okay? Now, next, modulus. Now, what is the meanings of modulus of a complex number? Normally we will give a complex number in the general form of z equal to a plus bi. We use the z to represent complex number. Z equal to a plus bi, where the a and the b are real and the I is the square root of negative 1. Already mentioned just now. Then the non-negative square root of the x square plus y square is the no, not the mistake again. This is a square plus b square. It's called the modulus of z. Some books they don't use a and b. Some books they use x and the y. That is why maybe because of that I make mistake in typing here. So some books they use x plus yi, but now we use a plus bi. But the meaning is the same. So you take the square root. This a square plus b square, the positive, non-negative means positive. The square root of this is called the modulus of z. And it is denoted as MODZ, or the 2 vertical bar, because the modulus z. Normally, I would prefer to use this second symbols. So mathematically, the modulus of z is the square root of a square plus b square. But what is the a square? A square is real numbers of the z, right? Square. And then b is the imaginary numbers, imaginary part, not number. Is the real part of the z. This one b is the imaginary part of the z. So you take the imaginary part square. You will get this modulus z. So example is this. Now if the z is 5 minus 3i, you find what is the modulus, or sometimes we call it the magnitude of the complex number. You will get z is the modulus of the z is 5 square plus negative 3. So when you substitute value, don't forget about this negative 3. If you compare with these standard symbols a plus bi, this one 5 minus 3i means that the b should be negative 3. Although there is a square here, and then after you take the square, the final answer is the same, but in the value substitutions, you must show me that you substitute correctly. You cannot say final answer is the same, then never mind. Please be rigorous. So if it is negative 3, then substitute negative 3. So 5 square plus 25 plus 9, you get square root of 34. This is very simple to find out what is a modulus. So of course later the things will become complex, more complex, and so we will combine everything to solve the tougher questions. Now is introductions. Okay, now it's already 3:50. I give you 10 minutes break. See you later.
Okay, thank you, sir. See you later too.
So later I will show you how to divide two complex number. It is a steps is different from the real number. But now we talk about the modulus first. If you take two complex number, you multiply them, you get a new complex number. Okay, and then you take the modulus. It would be the same as if you take the modulus of z1, z2 separately, two number, you divide them, you get the same answer. Provided, of course, z2 is not 0, because in mathematics, the denominator cannot be 0. If there's a 0, that means this expression is not defined. So z2 cannot be 0. Okay, so these properties you need to know. Okay, now we move on to the next one is the complex conjugate of a complex number. What is the meaning of complex conjugate? Let's say now we have this a minus bi. Just now we have a plus bi, same thing. Let's say now you have this a plus bi. The complex number is the one that a minus bi. If a minus bi is a complex number, then the a plus bi is the complex conjugate of it. So which one is called the complex conjugate? That one doesn't matter. But normally we will represent the z. In general, the z we will put it as a plus bi. But if you want to put it as a minus bi, also can. Depends. So now if a plus bi, then the a minus bi will become the complex conjugate of the complex number. Okay, so the complex number a plus bi and a minus bi are called a complex conjugate pair. They are a pair of complex conjugate. Now the symbols to represent this complex conjugate is z, on top we put a bar. Again, please, symbols important. I hope you don't trivialize it. So this is a z bar or the z asterisk. But I will prefer to use this easier, z bar. But some books they'll use z asterisk. So if the z is a plus bi, then the complex conjugate is a minus bi. Very simple definition. Now look at the example. Not example, the properties between the complex conjugate and the complex number. If a complex number z, you plus a complex number is complex number. If you take any complex number, you add with its conjugate pair, complex conjugate, you will get 2 times of the real part of the complex number. They say z is a plus bi. Then the conjugate should be a minus bi. You add them up, then the bi and bi will cancel out. So answer is 2 times of the real number. You will get a real number. But if you minus it, the real part will be cancelled out. Can see? It will remain 2 times of the imaginary part. It becomes 2bi. So this result is a real number. This one, the result is an imaginary number. But if you multiply them, z and the z conjugate, you multiply, you expand, you get a square minus abi. Can see? A times bi minus abi. The third term is abi again, but it's positive, and then this one negative b square I square. So the second and the third terms cancel out. Negative, this I square negative will becomes positive, so you get a square plus b square. But a square plus b square, this is a real number, right? What is the a square plus b square? You still remember this formula? Modulus. So if you take both sides square, the right hand side you get a square plus b square. So that means a square plus b square can be substituted or replaced by the modulus square. That's why we have the modulus square here. This is a very important formula. Z multiplied with the z bar will give you the modulus of the z square. Okay, I give you example, very straightforward example. All these example you can play around yourself. No need to get my example. Actually, it's very straightforward. You can ask your friends, call your friends, ask him or her to throw you a complex number, and then you just check, do all this checking. Okay, so now I give you this z plus z plus. So not z plus z plus z bar. You get this one first. Hey, I thought I already select this one. Okay, never mind. So this is 2, z is given by 2 times 2 square root 2 plus I 2 square root 2. So if you add up means that this one, you substitute this, you get this. And then real and real add up. This imaginary part cancel out. So actually you would get 4 times square root 2. So of course, again, if you know the properties already, you already know, then you can very fast, you can get directly take the real part and then multiply by 2. You'll get 4 sub 2. And then for multiplications, I show you the subtraction first. Subtractions then should be this, right? Substitute value, you should get this. And then you should get 2 times of the imaginary part. Imaginary part is sub 2i. So you get 2 sub 2i. So you see the I, sometimes you can write it in front of the numbers, or you can put it at the back also. Doesn't matter that one. And last one is a z times the z bar, the complex conjugate. So you substitute value, you should get this, correct? And then expand. If you before you know this formula, a squared plus b squared, of course you can expand one by one to get the 4 terms and then simplify. You simplify, you get answer should be this one z, correct not? 4r, yeah, negative 4i plus 4i, you see it will cancel. This one negative 2i square is negative 1, so that means 8 plus 2 equal to 10. So that means that if you already know the formula, you can directly take this a 2 sub 2, you take the square, plus this sub 2, you take the square, you get the answer is 10. If you already know this formula. If you do not know, then you expand it one by one, you'll get the same answer. Okay. Now next one is about the properties of the complex conjugate of a complex number. Again, I leave it to you as a home exercise, simple exercise. You just take any example of the z value and then check the properties to make. Of course, it is true, but no doubts, all these properties is valid one. But the reason I ask you to check is just to make sure you are very familiar with all these properties, because you need to apply it. Okay, so if z and z1, z2 are complex number, then you take 2 times of the conjugate. Z conjugate first time and conjugate second time, you get the same thing, z. Correct? Because let's say a plus bi. Conjugate becomes a minus bi. Conjugate again will becomes a plus bi. You will get back the same thing. Now, if this conjugate is taken between z1 plus minus z2, either plus or minus, you consider 2 cases here. Then this conjugate can be split. It will be the same as z1 conjugate plus minus z2 conjugate. Okay. And this one I already, no, sorry. If z1 multiplied by z2 conjugate, because z1 multiplied with z2, you get a new complex number. And then you take the complex conjugate. It would be the same as you take the z1 conjugate and z2 conjugate first, separately, and then multiply them. Answer would be the same. Similarly for division, you see this big conjugate can be split into 2. That means this one is cover both the numerator and denominator. Answer would be the same. Now this one is about the modulus. The z conjugate's modulus is the same as the modulus of the z itself. That means after you take the complex conjugate, it won't affect the modulus. It will maintain the modulus. Okay, and this z times z conjugate will be equal to the square of the modulus of the z. This one we already checked here. This is the one. This is how we check. So other properties you can also check like this. You use the a plus bi to check one by one. But also you can use the specific numbers to check that one. Also can. So if this one z inverse, if based on the property number 6, you can find what is the z inverse, because if this z you bring it to the right hand side, this square of the modulus you bring to the left hand side, you get the property number 7. Z inverse means how to find the z inverse. You can take the z itself divided by the modulus, the modulus square of the z itself, provided of course the z is not equal to 0, otherwise it wouldn't be defined. Okay, so this is all the properties which is you need to use it. And then now we move on to the divisions. Okay, divisions a bit different from the real number. Now, direct division by complex number cannot be carried out because the denominator is made up of 2 independent terms. Let's say for this example, denominator got real part and imaginary part. How can you divide? You can't divide this 2 plus 9i by another complex number. Unless this one is a real number, you can do. But now it is another complex number, you cannot do. So this difficulty can be overcome by making the denominator real. This is a complex number. We can, through certain steps, we can make it as a real. Then only we divide. So this process requires realizing the denominator. Okay, I give you one example enough. 2 plus 9i over 5 minus 2i. How to realizing the denominator? You multiply the denominator by its complex conjugate. So 5 minus 2i, the complex conjugate is 5 plus 2i. Okay, if denominator you multiply by 5 plus 2i, then of course numerator you have to multiply with same thing, 5 plus 2i. So the rest you already know. The rest we already discussed. Okay, so numerator you expand 4 terms, you get and simplify it, you get 10 plus 49i plus 18i square. You just expand. 2 times 5 equal to 10. This one 2i, this one 4i, this one 45i, so it's 49i, and then 9 times 2, 18i square. You can see this one you see is a complex number. I think this one, okay, you see, I think because I want you to apply this formula. Where is it? Just now, yeah, we apply this. No, the z. We apply this z times z bar equal to a squared plus b squared. So I think I changed this ways of presenting. So this one, instead of putting this, I think I use this one should be 5 square plus the b square. B square is what? B square is 2, right? So this is 2. You get 29. I apply the formula for z plus z conjugate, z times z conjugate. You get a square plus b square, a square plus b square. So this is now, you see, denominator becomes the real number. So now you can divide them to becomes 2 terms. So you see the final answer also is another form of a plus bi. Is a complex number again. Okay, so now with this, after you know how to divide 2 complex number, then of course now you can check these properties. You take z1 divided by z2, and then you get a complex number. You find out what is the modulus, and then this answer should be the same as the answer at the right hand side if you follow the different steps. Left hand side, one set of steps. Right hand side, another set of steps to find the answer. These 2 answers must be the same. Otherwise, this equality sign would not be valid. Understand? So same thing for this modulus. Just now I list out this one. So this is modulus. Just now another one is what? This one is about the complex conjugate. You already know how to do the divisions. Now the last concept for today is about the zero complex number. Zero complex number, actually we already mentioned just now. A complex number is 0 if and only if the real terms and the imaginary terms are both 0. only if the A and B both 0, then the Z itself is 0. Now, if the Z itself is 0, that means the modulus is equal to 0. Then how to represent this 0 complex number and any general complex number with a non-zero modulus? We will discuss this in the next class. So I think now it's a bit earlier, another 2 or 3 minutes. I think it's okay to stop here. It's enough for today. So I think I will later I will post the tutorial 3 up to these slides, the questions that you can solve, then you try to solve first, and the later part, then of course you can solve later. Okay, do you have any questions to ask?
So just for some clarification for slide 27, you make